In level 4, we now have to deal with an A value being something other than 1, but we're still going to move to get everything equal to 0 first. So we will add 5 to both sides, giving us 8a squared plus 14a plus 5 equals 0. Then we need to list out what a, b, and c are because there are no common factors, no GCF. So a is 8, b is 14, and c is 5. That means that a times c is equal to 40. So the top of our x will be 40, and the bottom of our x will be 14. The factors of 40 include 1 and 40, 2 and 20, 3 does not work, but 4 and 10, 5 and 8 work, and those are all of the factors. We want them to multiply to be a positive number, so 2 positives or 2 negatives will work, and add to be a positive number. So we want to leave them as 2 positives. That means that 4 and 10 is going to be my pair. We'll draw in our box next, putting our first term, which is 8x, or 8a in this case, squared, our last term, which is 5, in the first and last boxes respectively. Then 4a and 10a will make up our final 2 boxes. And remember, these are the only ones that can change the sign of what you are taking out of your box. Looking at the top row, what's the biggest number that can be divided into both 8a squared and 4a? That would be 4a. The biggest number that can go into 10a and 5 is 5. The biggest number that can go into both 8a squared and 10a is 2 and a. And finally, the biggest number that can go into 4a and 5 is 1. So our factors are 4a plus 5 and 2a plus 1. We'll need to set each of those factors equal to 0 to solve. So we'll subtract 1 from both sides, giving us 2a is equal to negative 1, and then divide by 2 on both sides. So a equals negative 1/2. For the next one, we'll subtract 5 from both sides, leaving 4a equals negative 5, and then divide by 4 on both sides so that a would equal negative 5/4. In example 1b, in order to get it equal to 0, we have to subtract 19b from both sides. So 0 is left on the left side, and we want to put our a term first, so the b squared term goes first. Then our b term, negative 19b, goes next, and then 12. Look for a GCF. Seeing there isn't one, we'll list our a, our b, and our c. A is equal to 4, b is negative 19, and c is 12. A times c equals 48. That means the top of our x will be 48, and our bottom for our x will be negative 19. Listing out the factors of 48, we'll have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 doesn't work, but 6 and 8 will bring up the end of our factors. For signs, our last number is positive, so two positives or two negatives, but the middle number is negative, so we want all negatives. That means -3 and -16 will be our factor pair. Here's our box. We'll put our first term, 4b squared, in the first box, and our last term, which is 12, in the last box, and our -3b and -16b will be in our last two boxes. Looking at the top row, the only thing that can be divided evenly into both of those terms is 4b. -3 can go evenly into both of those terms. Negative because this 3b was negative. The left side, only b. And the right side, a negative because the 16 is negative, and 4. So we'll have two factors of b minus 4 and 4b minus 3, and we'll set them both equal to 0. Add 4 to both sides, leaving us with b equals 4. And then this one will add 3 to both sides. 4b equals 3. Then divide by 4 on both sides. And b is equal to 3/4. So these are my two solutions. Let's look at example 2a. For example 2a, we want to make it equal 0. We also want to make sure that we're making the c squared term positive. We'll do both at the same time by adding 5c squared to both sides. So 0 is left on the left side, equals, and we'll put that term first because we want our c squared term to be the first term, then our c term, and then our constant. Look for a GCF, but there isn't one, so we'll label A, B, and C. A is 5, B is 7, and C is -6. We'll multiply A times C and get -30, making the top of our x -30 and the bottom of our x is 7. Factors of 30 include 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, but 5 and 6 do. We want them to multiply to be a negative, so only one negative and one positive would work. If we want them to add to be a positive, we'll want the larger of each factor set to be positive and the smaller one to be negative. That means that -3 and 10 would fit the bill. We'll put our box here and put our first term in the first box, 5c squared, our last term in the last box, and -3c and 10c will be the remaining two boxes. Out of the top row, only c can be removed. The bottom row, they both can be divided by 2. The left side, both of those terms can be divided by 5c. And the right side, we'll have to make sure we take a negative out because our 3c is negative, and they can both be divided by 3. So we'll have 5c minus 3 equals 0, and c plus 2 equals 0. Add 3 to both sides. So 5c equals 3. Then divide by 5 on both sides, giving c equals 3/5. For our other factor, we'll subtract 2 from both sides. So c equals -2. There are two solutions. For example 2b, we need to make everything equal 0. And remember, we also want to maintain our d squared term as positive. And I notice that I have d squared located on both sides of the equation. So I want to make sure that when I move them to the same side, that my ending number is a positive number. If I subtract 10d squared from both sides, I'll end up with a negative d squared. So I don't want to do that. Instead, we'll subtract 7d squared from both sides, which will give us a positive number. In the same step, if you'd like, you can go ahead and move your 2d to the other side by subtracting it. And there's already a like term here as well, so we'll write it right underneath. 10d squared minus 7d squared gives me 3d squared. 15d minus 2d gives me 13d. And then we have 12. We'll need to label our a and our b and our c because we don't have any common factors. A is 3, b is 13, and our c is 12. A times c is 36. So the top of our x is 36, and the bottom of our x is 13. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, and 6 and 6. The sign of our last number is positive, so 2 positives or 2 negatives. The sign of our middle number is positive, so we're going to use 2 positives. That means that 4 and 9 would be in our x. We'll draw our box. 3d squared would be in the first box because it's the first term. 12 is the last term, so it goes in the last box. And 4d and 9d will make up our last 2 boxes. What can be divided into both terms of the top row? 3d. Both terms in the bottom row can be divided by 4. The left side, both terms can be divided by d, and the right side, both terms can be divided by 3. So we'll set each of our factors equal to 0. 3d plus 4 and d plus 3 equal to 0. We'll need to subtract 4 from both sides. So 3d equals negative 4. Divide by 3 on both sides, and d will equal negative 4/3. Subtract 3 from both sides. D is equal to negative 3. And we have our solutions.